Hello all, welcome to Leetcode BiWeekly contest 172. We are solving all the problems here. So the very first problem that we are solving here is minimum number of operations to have distinct elements. So in this problem, we are given an integer array nums, and in one operation, we can remove the first three elements of the current array. If there are fewer than three elements remaining, all the three numbers are removed. Repeat this operation until the array is empty or contain no duplicate values. Return an integer denoting the number of operations required. So what it says is that we should not be having any duplicate values present in my array. And the operation that we can perform is we have to remove the elements from the starting. So if we are removing the elements from the start, that will gradually leave us that we should be focusing distinct elements from the end, right? So if you see this example, if I start looking at from backward side, so I take set, and in set I put 8, then I put 5, then I put 6, then I 3, then 8. Yeah, 8 is a duplicate element. So this is the until this point I have to do this operation. So what I'll do is I will start from a 0th index. I will start performing the operation. So what is the operation? That is first three elements of the current array should be removed. So I remove these first three elements. Now the remaining ones are all distinct. So I'm done. So only in one operation I was able to get all distincts. If we go with this approach, I started with here, I added another two, so it is already present in the set. So I need to remove elements up till here. So if when in one operation, entire array is gone. So yeah, in one operation is my answer. Let's start with here. 2, 1, 5, 3, 4. So since all elements are distinct, I never hit a position that a repeating element was coming. So yeah, don't need to do any operation over here. So what we'll do is I'll keep an unordered set. I will start my iteration from very last until 0. I will check what is the current size of my set. I'll store it in length. I will insert nums in my set. I will see that if length matches with current size, that is the duplicate element. Nums of I was a duplicate element. What I'll do is, since it is 0th base indexing, so I'll increase my I by 1. I will took the rate as basically what is the remainder that I get, if it is modulus by 3 or not. So for that sake, I'm just keeping if it is modulus 3 is coming 1 or 2, just increase it by 1, so that when I divide by 3, I should have that extra operation if I need to perform. And simply, if we gracefully exit this loop, we'll return 0. So yeah, that was all for this question. If we jump to next question, so this is maximum sum of three numbers divisible by 3. So in this problem, we are given integer array nums, and our task is to choose exactly three integers from nums such that the sum is divisible by 3 and return the maximum possible sum of such a triplet. If no such triplet exists, return 0. So we have to maximize such that the sum of the three, we have to explicitly select three numbers from my array in order to make it divisible by 3. So if individually I take elements, if every number's modulus I take, how can I make the sum of three numbers divisible by 3? If all three have the modulus 0, if all three has modulus 2, and all three have modulus 1. That is, for example, if I take 3, 6, and 9, all three have modulus 0. So their sum will be also divisible by 3. Otherwise, I take 4, 7, and 10. All their modulus 3 is 1, right? Or I take 5, 8, or uh, 11. All their modulus is coming 2. So these are the three sets that I need to take care. Apart from that, I just reorder. If you look at over here, 0, 1, 2, 1, 0, 2, or 1, 2, 0. So if I take modulus of like 1, 2, 3 consecutive, that is 1 modulus 3 is 1, 2 modulus 3 is 2, and 3 modulus 3 is 0. Let's take another example. Let's take 9, 26. This is modulus 2, and okay, 31. So 9 is modulus 3 is 0, 26 is modulus 2, and 30 is modulus 1. So if we take this sum, this will come as 66, which is again divisible by 3. So what I'll do is I basically create three vectors ABC. B is storing modulus 3 if it is coming out to 1. I modulus 3 is 2. I'm storing it in C. Otherwise, I'm storing it in A. I'm sorting all the elements. And if I go by the above four pointers that I mentioned, that if I take all three of 0, all three of 1 and all three of 2, these are the three cases, or if I just take the maximum of every arrays ABC. If I take biggest elements from A, biggest three elements from C, biggest three elements from C, sorry, and otherwise I'll take maximum from each of the arrays and update my answer accordingly. So yeah, this was all for this question. Now let's move to next question. So this question is maximum score after binary swaps. So in this problem, we are given integer array nums of length n and binary string s of the same length. Initially, my score is 0. Each index I where s of I is equal to 1 contribute nums of I to the score. I may perform any operations including 0. In one operation, you may choose index I such that I lies between 0 to n minus 1. And if s of I is 0 and s of I plus 1 is 1, swap. So this is important. Consecutive, I need to have 0 and 1 in my s. Then only I can do the swap. Return the integer denoting maximum possible score. So what this question says is I can do the swaps only if I have zeros just before the one. Uh, let's say this is my string, and let's say at the very last element of my nums is the maximum element. Since I have to maximize it, I can't take this maximum element. If at this position, if my this is 100 and rest are smaller elements, I can't do it. So if you assume that all the zeros at the right hand side or all the elements on the right hand side that are corresponding to s of I is 0, they won't contribute anything to my answer. So what I'll do is I'll take a priority queue. Why priority queue? Because it will give me the maximum element until the current point. I'll start my iteration from 0. That is basically I'm just iterating my nums. I'm just keep on pushing it. When I encounter s of I, that is whenever my s of I is 1, I will take the maximum element. Why maximum element? Because up till this point, let's say 0, 1, again 1, 1, again 0, 0, 1. Assuming I'm at this index, I can take maximum of whatever is present over here, right? I started my iteration from 0. Let's say I have some value, I edit in my queue. I edit in the queue, edit in the queue, edit in the queue, edit queue. Here also I will edit in the queue. Now at 1, I have the choice. Since I have 1 present there, I will take maximum of all the elements that I have encountered and that is sitting in my queue. I will take and add it to my answer. That is what I am doing here. If I encounter s of I is 1, add the queue dot top in my answer and just remove it from the queue. Simple. Again, this will continue. Now I'll start from here. Again, whatever is I'm keeping on adding it my priority queue. When I encounter this one, again, the maximum of second maximum, not exactly second maximum, the maximum, sorry, the maximum that is left, because I already consumed one element of from here. Now whatever is left, the maximum from that, again I will add it to my answer. So for this also similarly, maximum from the remaining, maximum from the remaining, and again maximum from the remaining. I don't care if after that I have 0, 0, 0, because that will keep on be adding in my queue, but that will never get consumed, right? So yeah, this was all for this question. Let's move to the very last question.